Hello my friend, how are you doing today? My name is Sarang Borude and I love building beautiful looking spatial computing apps. When I started with Vision OS development, I was overwhelmed by the options of adding 2D and 3D content to my app. I was confused by when to use Model 3D or RealityView and how to incorporate them in windows, volumes and spaces. So to understand this better, I created this dinosaur exploration app called Dinopedia. In this 3-part video series, we are going to dive deep into how this app was made. Each view in this app has used different ways of adding 2D and 3D content using SwiftUI. I highly encourage you to open the GitHub project that is in the description below and explore the views as we go through them in this video. You can tweak values and play around with the views to further your understanding. We're going to take a look at how to incorporate SwiftUI and add 3D and 2D content in your app, how to use Model 3D, how to use RealityView, how to use an IBL to light the environment, how to use manipulation gestures to manipulate your 3D models. So there's a lot to cover. I will be releasing the next parts every following week. So make sure you subscribe to the channel and enable the notifications so you know when the next one comes out. In this part, we will look at an overview of the project and look into how to add 2D and 3D content to windows and volumes. So let's get into it. Let's first look at how this project is organized. We are not creating a project from scratch, but it should be pretty straightforward. You just create a new Vision OS app with an immersive view, and that could be a good starting point. So this app has a bunch of views. The home view is the view that gets shown to the user when the app launches. And then there's the Dinopedia app struct. In this struct, we are defining all our windows and our volumes here and our immersive spaces. And we launch all our windows, volumes, and our spaces from the home view. You can see that I have some constants here that are for the view identifier. That's what we are using from other views to launch a specific view from the abstract. There's also some skyboxes that I have added here that we are using for the immersive views. And then there is this interesting folder with a .skybox extension, which is where we are going to keep our environmental light or IBL. And then we finally have our reality kit content and the packages. That's where all our models are living. So let's open it. So this is our reality kit content package. In this I have some models for our T-Rex and Stegosaurus, Brachiosaurus, Triceratops and Velociraptor. By the way, thank you so much Kenchu on Sketchfab. He created this amazing animated 3D models. I'm going to put the link for his models and his page in the description, so please check it out. But these are really high quality models that you can add to your scenes. Then there's this magnifying glass scene here that we are going to use for our very last view, and we'll jump back into Reality Composer Pro when we set this up. So now we are going to go into every single view and see how everything in this app was constructed. So when we launch the app, we start in the home view right here. So this is what the home view looks like. Let's take a look at its code. So you can see that home view, we have created some variables for exposing the environment actions for opening a window, opening immersive space and dismissing immersive space. Here from the home view, we are going to launch our windows and volumes and spaces. So you can see that it's simply a text label here that says welcome to Dinopedia. Then we have the VStack that incorporates basically 3 rows of buttons for each card that you can see here. So you can see that there is an edge stack with a button. The button basically has an open window action for windows and volumes. And then each button is constructed by using an image and a text, and that's a VStack. So that's what the visual for the button is. So you can see it here for the Velociraptor. For windows and volumes, we are basically using the environment action of open window, and we need to pass it the ID here, basically telling which window to open when this button is clicked. all these IDs are defined here in the Dinopedia app. So you can see that these are like static constants with just like text or strings that identify each view, and here you can see that each window group has an ID associated with it that is over here. So that's how we launch each view right here. For immersive spaces, if you look at the bottom, you can see we are using the open space function here. The open space function is defined at the bottom of this view. So let's take a look at that. So open space function, what it does, it dismisses if there is any already open immersive space, and then it opens immersive space with the specified ID. There are certain states that we can see here. So you can see when the immersive view is opened, if there is an error opening the state, if the user cancelled opening the state, all those things can be handled here. So I created the function here. So all you need to do is give it an ID of the space that you want to open, and it opens it. So that's pretty much it for what the home view is. So now let's try and open our first view, which is the Velociraptor card here. So I'm going to click on it, or rather spatial tab on it, and you can see this view over here. So let's now take a look at how this Dino card view was made. You can see that there is a 3D model of the dinosaur, and there is a floating button that says show model. There is some text on the top and bottom. So let's look at the code and see how this was made. So here you can see that for this view, I have a VStack going, and in that VStack I have some text for the title of the Velociraptor. I have some text at the bottom of the VStack as well. I've given it some frame and padding. Then I load the model 3D from our RealityKit content bundle with the name of Velociraptor. Once the model loads, this gives us the resolved model, and then I can apply some view modifiers to the model. So here I have made it resizable, so I can resize it to my liking. I've also added a scale to fit modifier, so the model of the dinosaur scales appropriately and in proportion. I have also applied a rotation 3D effect by rotating it by 90 degrees on the y-axis, so I see the side view on the card of the dinosaur. As the dinosaur model is loading, I have a placeholder progress view that kind of just shows some feedback to the user as the model is loading. To scale this model appropriately on this view, I have used two frame modifiers. We are using the frame modifier specifying 200 points for the depth, alignment, center, and the frame with a height of 200 points, and that gives us the size of the model that we kind of feel like it's fitting on the card. And then finally, I have added a SwiftUI overlay, and with the overlay I'm essentially overlaying a button with a button action of open window. So this opens the volume for the Velociraptor when we click the show model button. So that's what this specific overlay is doing. So one thing to note here, that we are using a model 3D and an overlay to overlay 2D content on top of 3D content here. And this does not need to be a button. This could be any SwiftUI view you can think of. So when we press the show model button, our app now launches the Velociraptor volume, and we can see the model of our dinosaur in its full glory. So now let's take a look at how this volume was made. So first, I would like to bring your attention here. So you can see that there is this window group with the ID of Velociraptor volume. It opens the Velociraptor volume view, which is right here. So when you look at this window group, you can see that I have set its window style to be volumetric, and its default size is 2 meters by 1 meter by 1 meter. Right, so now let's take a look at the code of the volume for the Velociraptor. So you can see that my Velociraptor is animating by spinning on the y-axis. So we can take a look at how that's done. So most of the things here are pretty similar that we have seen in the previous view. I'm using a model 3D, loading it from my RealityKit content bundle here. When the resolved model is given back here, I'm applying same view modifiers, resizable and scale to fit, and then I have a rotation 3D effect. I'm also applying a scale effect, more on that in a bit. So to animate the spin on this model, I'm using a timeline view. A timeline view takes two parameters. One is a schedule and a closure. So the schedule is basically how frequently do you want the update to happen. So I'm using animation as the schedule, and that basically means that this thing updates every frame. This also gives us a variable called context, the timeline view context, from which we can extract the current date, and from that current date, which is basically the current time, and we can say I want the time interval since the reference date. That gives us a double value aliased as time interval, and then you can multiply with some speed factor, rotation speed. So you can multiply this with some value, and that changes how fast this thing is rotating. So you can change this 10 to 20 and it will keep spinning faster. Okay, so one thing I want to bring to your attention is the scale effect here. So I discovered there are two ways to scale a model. So you can apply scale effect and pass a value into it, or you can use the same frame modifiers to essentially give it like a depth, width and height, and then your dinosaur can fit into it. Let's try experimenting a little bit with it. So you can see that I scaled the dinosaur very big, and you can see that the dinosaur is very big and it's getting clipped because my volume is only like 2 meters by 2 meters by 1 meter. But sometimes what happens is you don't even see your volume like this, right? It's pretty empty. So how to figure out what's going on? So I found out that Xcode gives us a neat little trick. So if you look at this very bottom button here, which says debug visualizations. So if you click on it, and if you enable your bounds and collision shapes, so you can see here in the simulator, we see the bounds of the model. So you can clearly see that our dinosaur is this white box right here, and it's not very visible, right? So you can basically get an understanding from this that our dinosaur is actually getting rendered outside of our volume. So we need to scale it down. So we can scale it down. I'll again revert back to the scale effect because I find that it's easier to scale the model like this compared to frame. So let's comment it. Let's scale it down to 0.6. Let's run it again and load our model. So we can see that the model kind of fits properly in the volume now. So now let's take a look at our second dinosaur, which is our Triceratops. Alright, so our Dino portal card is actually very interesting view. So you can see that it's a portal, the dinosaur is in the environment. I have some beautiful glass background effect on the text that's overlaid on it. And you can see that the dinosaur is actually inside the view, not outside it. So this creates a very nice effect of depth and looks very nice, as if you're seeing the dinosaur from a window. On this view, we have our button at the top that kind of launches the volume and some just informational text here, and you can see that there is an animation that's playing on the dinosaur. So we're going to see how this card was made. So our Dino portal card is essentially a Z stack with a reality view on the back and a V stack that has a button and some text at the bottom. The text at the bottom has some glass background effect. The button also has a glass background effect with some padding. When you press the button, it opens the Triceratops volume view that we are going to take a look at next. So a lot of stuff is happening in RealityView, and you can see that with RealityView we can make our 3D content more interesting, give it depth, give it some immersive feeling. So we can see in this card here that a lot of magic is happening in the RealityView. So we are creating a portal, and we are creating some content for the portal, and we are going to see this content only through the window of this portal. So in this video, I'm not really going to go super deep into how to create the portal, but I have a very interesting video that goes super in depth about how to create portals and portal related effects. So please check that out. The link should be right over here. So what is happening here? So I create my world, I set a world component on it, and then I create a skybox here, and I add that skybox to my world. Okay, so let's take a look at the create skybox function right here. So here what I'm doing is I'm loading a texture resource, and here it's the texture for the skybox that I showed you at the start of the project. So I'm just passing the name of the texture here. It loads the resource. Then I create an unlit material, and I essentially assign the texture to this unlit material, to its color component. And then I'm creating a giant sphere with the radius of 1000 meters, and I am setting our material, the unlit material we just created, to this model component of the sphere. Okay, and then what I'm going to do is I'm going to flip this giant sphere inwards by modifying its scale, and I'm returning this as the entity. So that's how we create the skybox, and our skybox gets added to our world. Now we are going to create our Dino, and to create our Dino, what we are going to do is we are loading it from our RealityKit content bundle, and I'm going to position it to my liking so that I kind of get this feeling that it's inside the portal. So I'm setting its position to -0.3, -0.5 in the z-axis, so it's perfectly positioned inside the portal just in front of the view. And I'm also scaling the Dino appropriately. So the Dino is loaded. Now I also want to play this animation that's going on repeatedly here. So if your model has any animations, you can find that out by checking the available animations on the entity that's just loaded. And then you can simply call a Dino, which is like your entity, and you can call the play animation function, and you can basically play whatever animation you have on the Dino itself, and then you can use this repeat modifier to keep the animation repeating. So you have total control over here. So that's the simple way to play an animation. This is how you can do it. A few people have asked me before, like, okay, so we have RealityKit entities, how do we actually light them? So here I'm going to show you how to actually light them with an IBL or image based light. So to do that, you want to add a skybox asset. It's an equirectangular image. The environment resource that you're loading for your image based light needs to be in this folder with a .skybox extension, and there needs to be only one texture in this folder. That's what the documentation said. So we'll do that. You'll also take a look at this file here. The resolution of this image is very low. It's like 1024 by 512 pixels. So if you use an image with a very high resolution, like let's say you use an 8K HDR map that you found somewhere, and you're trying to load this here, you will immediately notice that your app will crash. So just keep that in mind, that this file needs to be very low resolution. Okay, let's go back to our Dino portal card. So here what I'm doing is I am loading our environment resource named partially cloudy skybox that was in that folder. And once that is loaded, I am going to set two components on our Dino entity. I'm going to set an image based light component, and here I'm going to pass a single resource, which is our environment resource that we just loaded. And you can also set its intensity exponent here, which is basically how bright the light should be from this image. So if you increase it, the light on the Triceratop will look super bright. Now your Dino needs to have a image based light receiver component as well. And on this image based light receiver component, you need to basically tell it that my entity is the target to receive the image based light. Now that we have added our Dino, set its environment light, we can add it to our world now. Once we add them to our world, they are only going to be visible through a portal. So for that, we need to create a portal. So we create a portal using this create portal function right here. And here in this create portal function, we can see that we are generating a mesh resource, which is a plane. And I'm setting its width to be 0.4 meters by 0.4 meters and giving it a corner radius. That's how this corner radius comes to be. And then I am creating a model entity with the portal mesh that we just created as the mesh. and then I'm assigning a portal material to it. Okay, so once we have created our model entity, now what we are going to do is we are going to add a portal component to our portal, and then I'm going to add our entity, which is the world that we just created, as the target, and then we are going to return our entity. So let's go back. So you can see that here we are creating the portal, passing our world one that we just created here as a target, and then we are setting its transform so that it is rotated by 90 degrees in the x-axis, so it faces us, and I'm simply adding it to our RealityView content, and that's it. That basically gives us this view, and it's essentially a Z stack with a RealityView and some buttons and text. Now let's try to see how our Triceratops looks as a volume. So I'll press this button and open it. So let's take a look at our Triceratops volume view now. It's a very simple view. You can just see that it has nothing else but the reality view in it, the same way we are loading the model. So what we are doing here is we are loading the Triceratops model from our reality kit content bundle, setting its position, setting its scale here, and then we are finding what available animations are there, and we are just like finding the first one. We are playing the animation again with repeat modifier, so the animation keeps playing, and you can also set a grounding shadow component with the cast shadows flag to be true, and that basically allows you to your reality kit entity to have a shadow that falls gracefully on the surfaces. This is not working in the simulator, but this should work on device. Okay, so what I said is not entirely true. So you can see that here in simulator, I actually have a grounding shadow component on my Triceratops. So I came across this post by Volumetric, and here he clearly mentions that to add any grounding shadow component to any entity, it needs to be a model entity. So the idea here is that you enumerate the hierarchy of your USDZ file, and in that you find the actual entity that has the model component on it, and then you set the grounding shadow component on it. He has also provided us with this nice extension to entity that allows us to enumerate the hierarchy of the entity. So I have now incorporated this in the project in this file called entity plus extension. And you can see that it just traverses the hierarchy of the entity. And here in our Triceratops volume view, I'm simply enumerating the hierarchy, and in the closure, I'm simply checking if the entity is the model entity, then only I add a grounding shadow component to it. And if you do this, then your entity should have a grounding shadow component on it. Alright, now back to the video. Finally, we add our Triceratops to our reality kit content here. So one thing you should notice here is that I'm not setting any image-based light here, because when you run this on a device, what the model will do is it will just use the light from the environment of a room, so the model will more or less fit into the lighting of our room. So I don't need to add, since there is no environment here, I don't really need to add an image-based light. Just something to keep in mind. So we look at two separate volumes, one for the Velociraptor, one for Triceratops. And there is one important thing that you should keep in mind. Volumes are something that are relatively small. They're not super big. So you should not think about creating a ginormous dinosaur and put it in a volume. You should think of using volumes when you're placing something maybe right in front of you, maybe on a smaller table in front of you. So that's an ideal place to really put volumes. So the volumes dimension should be probably less than 2 meters by 2 meters by 2 meters. That's a bigger volume, but ideally, I think a meter cubed volume is probably a better size for a volume. So something you can probably like pick up, kind of like toy around, modify, just something to keep in mind. That is the end of this part. We looked at how we can add 3D content to windows and volumes using Model 3D and RealityView. We also looked at how we can add 2D content over the 3D content using overlays and Z-Stack. In the next part, we'll go deep into how to add 3D content and 2D content into immersive views. So make sure you subscribe to the channel and hit the notification button so you don't miss the next one. I'll see you real soon.